Have you ever asked yourself, what was there before everything? If you have, then you're about to embark on a journey back in time, to the very birth of the universe, to a period known as the Big Bang. Around 13.8 billion years ago, a moment arrived when all that exists, all the matter and energy, all the galaxies, stars, and even the potential for life itself, was not spread out across the cosmos as it is today. Instead, it was condensed into a singularity, a tiny point of infinite density and temperature. Imagine for a moment, every object you can see when you look up at the night sky, every distant galaxy, every shining star, every speck of cosmic dust, all compressed into a space so small, it's almost impossible to comprehend. But that's not all. Even time and space as we know them did not exist before this moment. They too were born from the singularity. Then something extraordinary happened. This singularity began to expand, not slowly or steadily, but explosively, rapidly. So rapidly, in fact, that we call this event the Big Bang. It was not an explosion in the traditional sense, but rather an expansion of space itself. As it expanded, it cooled, and the fundamental forces of nature that we know today started to take shape. From this rapidly expanding and cooling singularity, the universe was born. The energy that was once tightly packed began to transform into particles which later formed atoms, the building blocks of everything we see around us. So when you gaze up at the night sky, remember this. Every galaxy, every star, every planet, even our own Earth, they all share a common origin. They all emerge from that initial singularity, from that single point of infinite density and temperature. That's the beauty and mystery of the Big Bang, the birth of our universe. Imagine all the galaxies, stars, and planets, including our Earth, originated from that one single point. How do you think the galaxies and stars that we see today came into existence? A question to pique your curiosity, isn't it? The answer, my friends, lies in the tale of the universe's expansion and cooling. As our universe began to expand from the Big Bang, it was extremely hot and dense. But as it stretched and grew, it cooled down. This cooling allowed for the formation of the smallest building block of matter, the atom. Initially, these were predominantly hydrogen and helium atoms, the lightest elements in the universe. With the formation of atoms, the universe was no longer a plasma soup, but rather a cosmic gas cloud. These atoms didn't stay solitary for long. They began bonding together, forming molecules. With time, these molecules became more complex, and the universe was filled with clouds of gas and dust. Gravity, the great sculptor of the universe, then took center stage. It began to pull these atoms and molecules together. The denser regions attracted more matter, and these clumps of gas and dust started to grow larger and larger. These are the birthplaces of galaxies and stars. Inside these massive gas clouds, pockets of gas and dust started to collapse under their own gravity. As they collapsed, they spun faster and got hotter, eventually igniting the process of nuclear fusion. This is how a star is born. But stars aren't eternal. They live, they grow, and they die. In their death throes, stars explode in spectacular supernovas, scattering their enriched guts across the universe. These stellar remnants, full of heavier elements like carbon, nitrogen, and oxygen, become the raw materials for new stars, planets, and eventually life. So in essence, we're all made of star stuff. Every atom in your body, the device you're listening on, was once part of a star that exploded. Now, isn't that a mind-blowing thought to ponder? Ever wondered how our home, the Earth, came to be? Let's take a journey back in time, about 4.6 billion years ago, to the birth of our solar system and Earth. In the beginning, there was just a nebulous cloud of gas and dust, a cosmic soup floating aimlessly in the vast expanse of the universe. But then, something triggered a collapse. The cloud began to shrink under its own gravitational pull, becoming denser and hotter at the center. It was a tumultuous, chaotic time, but out of this chaos, our sun was born. Yet the story doesn't end there. The leftover gas and dust, still swirling around the newborn sun, didn't just disappear. Over millions of years, these particles began to stick together, clumping into larger and larger pieces. Tiny specks of dust turned into pebbles, pebbles into boulders, and boulders into planetesimals. These planetesimals collided and merged, eventually forming the planets of our solar system, including our very own Earth. Our early Earth was a violent and inhospitable place, bombarded by comets and asteroids. But it was these very comets that brought water to our planet, filling our oceans and setting the stage for life. As the Earth cooled, an atmosphere formed, shielding the planet from harmful solar radiation and providing the air we breathe today. From a cloud of dust and gas to a bustling planet teeming with life, our Earth has undergone a remarkable transformation. It's a journey of billions of years, but one that's etched into every rock, every ocean, and every living creature. So, next time you gaze up at the night sky, remember this. Our solar system, our Earth, and even we ourselves are products of cosmic processes that began billions of years ago. We are all children of the stars, born from the same materials that make up the universe. So in a way, we are all made of stardust. From single-celled organisms to intelligent beings, how did life evolve on Earth? Life on Earth began with single-celled organisms, microscopic in size but monumental in significance. These early life forms, known as prokaryotes, were simple in structure, lacking a nucleus and other cellular organelles. Yet they set the stage for the grand drama of life that was to follow. Gradually, over billions of years, these single-celled organisms evolved into more complex forms. Cells with a nucleus, or eukaryotes, appeared. Multicellular life forms began to emerge, diversifying into the myriad species we see today. From delicate butterflies to towering trees, from microscopic plankton to the mighty blue whale, life on Earth is a testament to the power of evolution. Then, about 2 million years ago, a species emerged that was unlike any other. This was Homo sapiens, or wise man, and we are their descendants. Humans were not the strongest nor the fastest, but they had something no other species had: intelligence. This intelligence allowed us to develop language, culture, and technology. We began to understand the world around us, the laws that govern it, and our place within it. And this understanding has led us to the stars. We've sent probes to distant planets, landed men on the moon, and peered into the far reaches of the universe with our telescopes. We've discovered galaxies, black holes, and exoplanets. We've unraveled the mysteries of time, space, and matter. And yet, despite our knowledge, we remain humble. We know that we are just one species on one planet, circling one star in a galaxy of billions. We are a tiny part of a vast and wondrous universe. But perhaps, in our quest to understand the universe, we have discovered something even more profound. Through our intelligence, our curiosity, our capacity for wonder, we have become the universe's way of understanding itself. We, humans, are the universe's way of understanding itself. What does the future hold for our universe? As we gaze into the cosmos, we can't help but wonder about the destiny of this vast expanse we call home. Theories abound, each as intriguing and mind-boggling as the next. Three of the most prominent are the Big Freeze, the Big Rip, and the Big Crunch. The Big Freeze suggests that as the universe continues to expand, it will gradually cool down. Over countless eons, stars will burn out, galaxies will drift apart, and eventually all activity will cease. The universe will become a dark, cold, and lifeless void. In contrast, the Big Rip theory posits that the universe's expansion isn't just continuing, it's accelerating. If this acceleration persists, it could eventually overcome gravity, ripping apart galaxies, stars, planets, and even atoms themselves. Imagine a universe that tears itself to shreds, leaving only isolated particles in a sea of expanding darkness. Then there's the Big Crunch. This theory proposes a universe where expansion slows, stops, and reverses. Galaxies, stars, and all cosmic matter would be pulled back together in a cataclysmic implosion, potentially leading to another Big Bang and a new universe. These theories might sound bleak, but they're based on our current understanding of the universe's expansion. New observations and discoveries could completely change our predictions. After all, we are exploring the vast, complex, and often surprising cosmos. And while the universe's future may be uncertain, Our role as curious observers is not. As we continue to push the boundaries of our knowledge, we unravel the mysteries of the cosmos, bit by bit. Each new discovery brings us closer to understanding our place in this grand cosmic story. So, while we ponder on these theories and continue our exploration, we must remember that we are a part of this universe's tale. We are stardust, born from cosmic events billions of years ago, now sentient, studying the very universe that created us. While the future of the universe is uncertain, one thing is clear. We have a unique opportunity to learn and explore this cosmic home of ours.